Hello everyone, I'm physics teacher and welcome to my podcast where I attempt to teach high school physics and chemistry concepts to my daughter in elementary school. Say hi, Coins.
Hi.
Be sure to listen to the end to see how she does on her final quiz of 5 questions. If you enjoy it and want a second season, let us know. This is episode 6, our final episode of this season where I try to teach her about the mole and stoichiometry. So first, Coins. How many shoes do you have in a pair?
2.
Okay, so if I had 2 pairs of shoes, how many shoes would I have?
2 pairs.
How many shoes in
4.
total? 4 shoes, okay. How many donuts are there in a dozen?
12.
Okay, so if I had 2 dozen donuts, how many donuts do I have?
24.
There we go. All right, if I had a cup of water, how many molecules do I have?
I'm not answering that.
It's a little bit of a harder question, and we certainly need a better way to count molecules, right? So Avogadro has a special number, of course, called Avogadro's number, and his number is 602 billion trillion.
What?
Yeah, 602 billion trillion. So instead of saying a dozen donuts or a pair of shoes, we can say, for example, a mole of water. A mole is 602 billion trillion molecules.
Specifically 602 billion trillion?
Yes. Yes.
So if it's not 602 billion trillion, it's not a mole?
That's correct.
That sucks.
Well, I mean, if it's not 12 donuts, it's not a dozen, is it? If you went to Tim Hortons and ordered a dozen donuts and you got 10, how would you feel?
I would feel scammed because I'm paying for 12 donuts.
Exactly, right?
But this is different. I'm not paying for 602 billion trillion.
Well, what if you go buy a bottle of water? Now, if you go buy a bottle of water, they will tell you like volume, right? Or you might read things in grams, right? So you might have volumes or mass, but there's a way to convert that, and we're not going to go over conversion.
Wait a second.
We can count.
So water is more of 602 billion trillion, but it's a specific amount. So if it's like 1 tablespoon more, then it's not a mole.
Yes.
That sucks.
So there is a way, if you were to have a certain amount of water in a cup, there is a way to calculate how many moles of water in that cup. We're not going to go over how to do the calculations. Maybe we'll save that for season 2. But let's say you had 5 moles of water in your cup. Then you would have...
How do you get that exact amount? Because aren't molecules like super small and like 1 extra drop is another 100,000?
Molecules are super small, but here's the thing. We know the mass of a water molecule, right? And if we know the mass of a water molecule, and let's say we know the mass of a cup of water, then we can figure out how many water molecules there are. But the number is just so big, we don't want to talk about billions and trillions of water molecules.
That's why we call tablespoons teaspoons.
What?
Tablespoons teaspoons. That's why we say tablespoon teaspoons, question mark?
I don't know about that, but that's why we come up with different ways of counting something. Right?
Interesting.
Like if you went to the beach and I gave you a cup and I told you, get me 100 billion sand particles.
I would refuse.
Yeah, but what if I just said, get me 1 cup of sand?
I would also refuse.
Well, that's rude. But it would be a lot easier to do. So what we do is we have the mole defined as Avogadro's number, 602 billion trillion particles, or atoms or molecules. Okay? So if you had 2 moles, you would have 2 times that amount. 3 moles, 3 times that amount. Okay?
Okay.
All right. So now that we know how to count particles, let's do some stoichiometry. That's a fancy word, but basically it's looking at how much reactants and how much products we have in a chemical reaction. But let's do something simple. Remember when we went camping and we made s'mores?
Yes.
Okay, what do you need to make s'mores?
Okay, so you need a fire. You need a stick. You need wood to make the fire. You need graham crackers.
Okay. Grandma crackers?
You need graham crackers?
Graham crackers.
Graham crackers?
There you go.
Chocolate is optional.
No, it's not. It's mandatory.
What?
Chocolate's mandatory.
No.
Yes, it is.
Okay, chocolate.
And forgetting the most important thing here.
The marshmallow.
The marshmallow. Okay. So let's not worry about what we need to make the fire, but to make the s'more, we need crackers, chocolate, and marshmallows. How many crackers do you need to make one s'more?
2.
2. Okay. How many chocolates?
Well, that depends.
For you?
1.
1. Oh, okay. And how many marshmallows?
1.
Okay. So 2 crackers, 1 chocolate, and 1 marshmallow gives you 1 s'more. This is essentially stoichiometry. We're looking at how much of the stuff we need to make something.
Wait, so we're looking at like cooking and baking?
Essentially, yes, that's chemistry as well, right?
Mm.
So let me look at it this way. Now let's say I were to give you 4 crackers.
I would eat them.
Hold on. we're still making s'mores. 4 crackers, 2 chocolates, and 1 marshmallow. How many s'mores can you make?
1.
1. Why?
Because you need 2 marshmallows.
Okay, so I didn't give you enough marshmallows, so that the marshmallows are what we call a limiting reagent, meaning it's the stuff you have the least of out of all your cooking materials.
Okay.
Okay. Now, if I were to give you 100 crackers,
Why would I want that many?
I don't know. You're really hungry. And 5 chocolates and 2 marshmallows. How many s'mores can you make?
Let me think. 2.
2. So what's your limiting reagent? What do you have the least of?
Marshmallows.
The marshmallows.
And the chocolates.
Well, the chocolates, we still had some left over after making 2 s'mores.
But we had 100 graham crackers.
True. Okay. But the chocolates and the graham crackers are left over, so they are called in excess.
So they're just excess?
Not excess, meaning we have more than what we need.
Okay.
Okay.
What is water scamochi?
Stop reading my notes. That's stoichiometry. Okay, so now to make water, we're gonna do more of a chemical reaction now. So to make water, we need hydrogen and oxygen, but we're going to count with moles. So to make water, we need 2 moles of hydrogen.
Okay.
Okay, and 1 mole of oxygen.
Okay.
And that'll actually give us 2 moles of water.
Okay.
Okay. So how much water can I make if I have 4 moles of hydrogen and 1 mole of oxygen?
1, 2.
2.
There you go.
Right? What's your limiting reagent?
The oxygen.
Good. And what's in excess?
The hydrogen.
There you go.
Yes.
All right, quiz time.
Yay. I'm going to get 5 out of 5 stars like last time.
I don't think you got that last time. Anyways.
I don't think so.
Question 1. How many molecules of water are in 1 mole?
Okay, so it says here 602 billion trillion.
Yes, okay. Now, normally I ask my chemistry students to memorize that number, but...
it's written down.
Okay.
Like, how is that helping?
Okay, when you get to high school, you have to memorize that. Okay, next. What is that special number called for the number of particles in 1 mole? What's it called? It's somebody's number. Whose number?
Avogadro's number.
Okay, you're just reading.
You tried to scroll down.
I tried to scroll down, but I was too late. All right, Avogadro's number. Okay, now it's going to get harder. If I have 5 crackers, 5 marshmallows, and 5 chocolates, how many s'mores can I make?
2.
2.
Exactly.
Good. And what was the limiting reagent?
Isn't it like all of them?
No. 5 crackers, 5 marshmallows, and 5 chocolates. Remember how many of each you need.
Crackers.
Yes. Okay, because you need 2 crackers for a s'more.
This is easy.
Okay. You got 4 out of 4. The last question is really easy. Now that season 1 is over, did you prefer the first 3 episodes on physics or the last 3 on chem?
Last 3.
Oh, wow.
Sorry about that.
That's all right. We're just going to have to change the name of the podcast from Little Astrophysicist to Little Chemist. We'll do that for season 2. Thanks for listening.